So we have the large and the small. So just picking a side, it has to be like a corresponding side. So I chose the height. If you want, you could have chosen 9 and 6, and you would end up with the same ratio when you put them into a fraction. But I chose the height for both, which doesn't really matter what you do. And then we're going to write this over here. This is the old shape. This is the new shape, because we're just going right to left. So old to new. And then you may notice, oh, this is not there, but old, or sorry, switch that. New over old is what it needs to be. I really thought I already had that printed on here, but I guess not. So, new over old. New versus old, 8 over 12. We simplify that to 2/3. Great. Now we have, this is our scale factor. So today you're going to be doing a delta math, and it's going to give you a scale factor every time, which just shows the relationship between the two shapes. Okay? This is, basically, this shape is 2/3. The new one is 2/3 the size of the old one. If that number is greater than 1, if the number was 2, that would mean that the new shape is twice as big as the old one. That's all the scale factor is what you multiply it by. We talked about scale factor when we did dilations in the first unit. We talked about scale factor when we did similarity. This is the 3rd time this semester that we've talked about scale factors. It's the same thing, nothing different. All right, here's the surface area of these two shapes. So we're just going to write these down, 540. And we're just going to say these are inches. Why not? Just for funsies, so we have a unit. We're just going to say inches. Why not? Inches squared. 240 inches squared. Here's the volume, 648. 648 inches cubed. So one thing I want to point out is surface area is squared, volume is cubed. I'm just going to write it there so we remember that. 192 inches cubed is the volume of the smaller shape. All right, now we can make our fraction, so our scale factor of the surface area, which is still new over old. So 240 over 540. And then make sure we know how to type this into the calculator. I mean, you could just look at it and simplify it on your own, or you can type it into the calculator, whatever you choose to do, but I'm going to choose the calculator. All right, 4 over 9. Okay, to the next one. 192 over 648. 192, 648. And we get 8 over 27. Now we're going to talk about like the relationship between these. The relationship between the 3 scale factors. So if you start with 2/3 and you are figuring out the surface area, you need to square it to get 4/9. So the surface area is squared. If you start with 2/3 and you are trying to figure out the ratio of the volumes, or the scale factor of the volumes, you cube it to get 8 over 27. We're going to answer this problem. All right, so draw this line here. We're going to write surface area, and then we're going to write this formula down. So everyone should be writing. Surface area, volume. This surface area formula is 2 pi r h plus 2 pi r squared. The volume formula, and I'm going to freeze the screen so that you can see over my hand. All right, so write this down. This is the surface area of the original shape. So we will find the surface area of the original shape, and then we'll take that scale factor, and for surface area, we will square it, multiply it by that original surface area, and then we have the surface area of the second one. All right? Okay. So in order to do that, we're going to, it says also answer in terms of pi. So don't put pi in the calculator. 2 times 10 times 9. You get 380 pi. We can't really see that. All right, 380 pi. But we want that. Here's what I think like confuses people the most is because they see 1/2 and then they're like, all right, I just need to cut that surface area in half. But no, that's not what's happening. What's happening is you are dividing the 10 by 2 and you're dividing the 9 by 2. And then you're figuring out the surface area, which the change in the surface area is actually that number. One over 4. No, I shouldn't do that. 1 over 2 squared. So 380 times 1/2 squared, which ultimately is multiplying it by 1/4. Because remember, you don't put pi in the calculator. So I'm going to write that here because you're probably like, wait, where'd pi disappear to? Don't put pi in the calculator. Oh, it should be 1/2, yes. What you're doing is multiplying by 1/4, but 1/2 squared is 1/4. So I wrote the wrong thing, but thank you. Yeah, so this is 1/2. You just take the square factor and you scale it. So 95 pi would be your answer. All right, you're going to do the same thing for the volume, except instead of squaring it, you're going to cube it. So volume equals pi times 10 squared times 9. 10 squared times 9. So 900 pi is like the original initial volume. Okay? So we are going to take 900 and we are going to multiply it by 1/2 cubed. And then what happens here? So it ends up, this is like a fraction, but you can do one of two things. You can click math and click 2, and it will turn it into a decimal. I don't know if it will accept it in delta as a fraction like that. So I would just convert it to a decimal.